To analyze a truss with the method of joints, follow these steps. First, identify all truss members and forces. Second, determine which members are zero force members. Finally, solve for the forces acting on each joint. We'll be analyzing this truss. Here is its free body diagram. The truss has 13 members and is attached to a rigid wall at these locations. There are two types of forces that act on the truss: external forces and reaction forces. The only external force acting on the truss comes from the weight hanging from joint E. There are two reaction forces, or one per attachment point. Since the attachment points are pin joints, these reaction forces have both X and Y components. If the truss were three-dimensional, they would have X, Y, and Z components. Note that we usually assume that truss members are massless, so gravitational forces acting on them are ignored. Let's determine which members are zero-force members. Most zero-force members fall into two categories. When two non-collinear members meet at a joint without external forces acting on it, both are zero-force members. When three members meet in a joint without external forces acting on it, and two members are collinear, the third member is a zero-force member. These members fall into the first category and are zero-force members. These members fall into the second category, so this is a zero-force member. As a result, these members act like a combined member. Their forces are the same as the combined member's force. Note that because the external force acting at joint E is vertical, and this member is horizontal, it is also a zero-force member. Now that we've identified all zero-force members, we can solve for the forces acting on each joint. We'll start with this one. Since truss joints are static, we know that the sum of the forces acting on the joint is zero. This means that the sums of the X and Y components are also zero. There are two forces acting on the joint, member 9 and the external force. Since both are vertical, no horizontal forces are involved. As for vertical forces, here's the equation. We assume that the member forces point away from the joint, meaning that they are in tension. If they turn out to be negative in the calculations, it means that the member is actually in compression and that the member force points towards the joint. By convention, upwards and rightwards are positive. Solving the equation tells us that the force acting on member 9 is 100 newtons, and that member 9 is in tension. Now, let's move on to joint C. Here are the equations for the X and Y forces. The X equation tells us that members 4 and 8 have forces of the same magnitude, but in opposite directions. This means that one is in tension and the other one is in compression. Once we know this, we can easily solve for members 4 and 8 using the Y equation. Next, we can solve for joint B, then joint F, and finally joints A and G to solve for the reaction forces here. This gives you these results. If this video was helpful, please like and share it and consider subscribing to this channel.